So let's try another example. This time we're rotating the graph of y equals 2x squared plus 1 from x equals 0 to x equals 1. Now, there's a very important difference in this example, which is that we're rotating around the y-axis. Now remember that our surface area formula that we learned before used the x-axis. So we had the x-axis before. That means we need to convert our surface area formula to adapt for the fact that we're now rotating around the y-axis. So that means we need to look at the surface area formula and kind of switch everything from x's to y's. So let me write that down. The surface area is now the integral from y equals, I won't write a and b, c to y equals d of 2 pi f of y times the square root of 1 plus f prime of y dy. So that means we need to convert everything here into functions in terms of y, including our function and the limits, because we were given this as if it were y is a function in x. Instead, we need to convert everything into x as a function in y. So let's go ahead and convert that. Looking at the function first, we get y minus 1 equals 2x squared. And we can divide both sides by 2 there. So x equals the square root of y minus 1 over 2. If you plug in x equals 0 into the function, that would convert into y equals 1. If you plug in x equals 1 again into the function, that would convert into y equals 3. So now we have everything in terms of y. Again, let's try to figure out what f prime of y and what this square root formula turns into. So f prime of y, well, we've got something, a square root of something, so its derivative is 1/2, because we think of the square root as being all of that stuff to the 1/2. 1/2 times all of that stuff to the negative 1/2, so I'll write it down here in the denominator, y minus 1 over 2, times the derivative of that inside stuff by the chain rule, and the derivative of y minus 1 over 2 is 1/2. So let me try to simplify this. I'm going to put the two halves together and put 1/4. And now this denominator, I'm going to flip it and bring it up to the numerator, so that's 2 over y minus 1. So that's f prime. We need to find f prime squared is 1/16 times 2 over y minus 1. And we could simplify that into 1 over 8 times y minus 1. 1 plus f prime squared, f prime of y squared, is, well, 8 times y minus 1, 8y minus 8 plus 1 over 8y, 8 times y minus 1. So what I did there was I wrote that 1 as 8y minus 8 over the denominator, 8y minus 8, because I wanted to combine everything over a common denominator there. So I can simplify that down a little bit into 8y minus 7 over 8 times the quantity y minus 1. And now we need to take the square root of that. So what we have is the square root of 1 plus f prime of y squared is the square root of 8y minus 7 over 8 times y minus 1. And so I'm going to put all these pieces together into a big integral. The surface area is the integral from y equals 1 to y equals 3. got those from here and here. And 2 pi. F of y, I got that from here. So that's the square root of y minus 1 over 2 times the square root of 1 plus f prime of y squared. So that's 8y minus 7 over 8 times the quantity y minus 1. All of this times dy. Now that's looking pretty messy, but it does simplify. The y minus 1's cancel, and then we're left with a 2 and an 8 in the denominator. That's 16. We could pull that out of the square root and make that a 4 in the denominator. So this simplifies down a bit to 2 over 4 gives us 1/2. I'll pull the pi outside. So we get the integral from y equals 1 to y equals 3 of the square root of, I think the only thing that's left there is 8y minus 7 dy. And now we can use u equals 8y minus 7. So du equals 8 dy. And dy is 1/8 du. So what we get now is pi over 2 times the 1/8 that we got from the du here. The integral from y equals 1 to y equals 3 of u to the 1/2 du. So that's pi over 2 times 1/8. U to the 1/2, the integral of u to the 1/2 is u to the 3/2, divided by 3/2, which is the same as multiplying by 2/3. And we want to evaluate that from y equals 1 to y equals 3. So I can simplify a little bit. My 2's cancel. We get pi, combine the 3 and the 8 over to give 24. So that's pi over 24. Now, u was 8y minus 7. So that's 8y minus 7 to the 3/2. So finally we get pi over 24 times, now if we plug in y equals 3 to 8y minus 7, that's 24 minus 7, so that's 17 to the 3/2. If we plug in y equals 1 to 8y minus 7, that's just 8 minus 7, so minus 1 to the 3/2. And we can clean that up a little bit into pi over 24 times 17 root 17, that's 17 to the 3/2. 1 to the 3/2 is just 1. So our final answer is pi over 24 times 17 root 17 minus 1. So probably what made that problem difficult, besides it being a little bit complicated on the algebraic side, was the fact that we were given the y-axis instead of the x-axis, which means you have to take your original x formula and translate everything into terms of y. And then in turn you have to translate from y as a function of x to x as a function of y. And any x values that you're given have to be converted into y values. Once you do that, you walk through the process of calculating this radical, 1 plus f prime of y squared, and then it's still kind of a messy integral, but the square roots sort of cancel nicely and you end up with something that's not too complicated at the end.